Previously, we evaluated limits using what I call the Sloth Definition, kind of the lazy way of going about it, which amounts to, because it looks like it. The limit exists if the intended height from the left and the right are the same. So if you look at the graph of a function and you're finding the limit at an x value, if you see that there is a hole in the graph or the curve is smooth there, well, the limit is going to exist. We're going to be able to find an answer. But if you just look at the graph and you see at that x value there's a break in the graph or an asymptote, well, you immediately know that the limit does not exist. Well, on the AP exam, you can't say the limit does not exist because it breaks there or because there's an asymptote. You have to list out 3 steps. You have to explain the formal definition, and that's what we're going to be doing today. So let's get to the formal definition of a limit. It has 3 parts. The function f is going to have a limit at some number a as long as, now it says exists if and only if. IFF in math stands for if and only if. So it's going to exist if, this is the formal notation that must be used, the limit as x approaches the number a from the left has an answer. The limit as we get close to the number a from the right has an answer. And then also the limit from the left equals the limit from the right. The notation I have here is the notation we have to use on the AP exam. Let's take a look at several examples where you're going to need to find the limit at an x value, so you'll evaluate it, but also you have to justify your answer. There are several problems on the AP exam that are multiple choice where you would not have to justify your answer. That's why this sloth definition is really handy. If we're asked at what x values the limit doesn't exist, we can just start looking from left to right, and as we start looking, we're looking at -8, -7, all these numbers, and then at -5 we have an asymptote. Well, we know that at -5 that the limit is not going to exist because there's an asymptote. How about at -1? We keep on following this function. At -1 we have a hole. Well, we know that holes are okay for limits. So -1 we're just fine. We keep on looking and we get right here at 2. Is the limit going to exist at 2? Holes are okay. It's all right that this is filled in up above. So the limit will exist at 2. It will happen to equal 2, coming in from the left and the right. Okay, so keep on going. And what about 3.5? At 3.5, we're right about there. See how the curve is smooth right there? We don't have any breaks or any holes. Well, of course, we can find limits when the curve is smooth. Finally, let's look at 6. And at 6, uh-oh, we have a break. So we know the limit is not going to exist at 6. This strategy, using the sloth definition of breaks and asymptotes are not okay, we can answer multiple choice questions really quickly. But we're going to get past because it looks like it. So here we go. We're going to use the 3-part formal definition to find the limit as x approaches -5 of g of x, and then we want to justify it. On the AP exam, on these extended problems, if you have the correct answer but you don't justify, you do not get either point. So you need to have the correct justification to get the correct answer point. So let's first just get the correct answer, even though I know we're going to need to justify. At -5, we see we have an asymptote, so we know the limit here is not going to exist. But this is just that sloth definition. It is not okay to say The limit as x approaches negative 5 of g of x doesn't exist because I see an asymptote. What you have to write is the three-part formal definition. All right, so starting with number 1. The function here is g of x, and we're getting close to negative 5. So we're going to say the limit as x approaches negative 5 from the left of g of x, and then let's take a look at that. If I start moving along here, getting close to negative 5 from the left, see how we're heading to a height of infinity? So I'm going to say equals infinity, but that's really the same thing as does not exist. If you remember, infinity is a concept, it is not a value. So already, part 1, the limit as x approaches negative 5 from the left does not have a value. As soon as we break one of these parts, 1, 2, or 3, we really don't need to go on. It's much easier to disprove something because as soon as you find one issue, then it's not going to work. So I'm not going to worry about steps 2 and 3, and I'm going to say therefore, those 3 dots like that is a universal symbol for therefore. The limit as x approaches negative 5 of the function g of x does not exist. So if you were asked to evaluate and justify, you would need to write all of this. All right, let's look at another one. Okay, we want to evaluate and justify the limit as x approaches negative 1. Now we look at negative 1, what's happening there, and there's a hole. And we know from the sloth that holes are okay. We are going to have an answer to the limit. But we are going to have to, instead of just glancing and saying, oh, from the left and the right, we're heading to a height of 3, knowing that we are going to have an answer of 3, we need to actually justify. All right, so let's use that formal definition. I feel like I'm moving all around. Okay, here we go. So, step number 1. The function that we're dealing with is called g of x. So I'm going to write the limit as x approaches negative 1 from the left, so that little negative up there of the function g of x. Now let's take a look. Let's move coming in to negative 1 from the left. See how we're heading to a height of 3? All right, so it does have an answer. It happens to be 3. Number 2, we want to find the limit as we approach negative 1 from the right. So we have to write the notation there, and then I'm looking, we're moving in from the right, and notice as we get closer and closer to x equals negative 1, we are heading to a height of 3 again. Step 3, we want to be able to say the limit from the left is the same as the limit from the right. And they are. The limit from the left was 3 and the limit from the right was 3, so 3 equals 3. So now we can declare, therefore, the limit as x approaches negative 1 of g of x is equal to 3. Again, if you were on a multiple choice question on the AP exam and you just wanted to find the answer to the limit as x approaches negative 1 of g of x, you could say, oh, negative 1, there's a hole, holes are okay, and I come in from the left and the right and I go to a height of 3 and I'm good. But if this is an extended response where you have to justify your answer, you can't just say the answer is 3 because there's a hole there and holes are okay. You must write all of this down. All right, here's another example. We want to evaluate and justify the limit as x approaches 0 of g of x. I already put here that it's 3 because we know that it's going to equal 3 because if we go to 0, we can look right above 0 and see that this is a smooth curve. And limits are okay. Limits, we can find them at 0. If I come in from the left and the right of 0, from the left and the right, the height is heading to 3. All right, but we're going to throw this away because we're going to use the formal definition. All right, so 3 steps. Step number 1, the limit as x approaches 0 from the left of g of x. So coming in from the left, getting closer and closer to x equals 0, see that we're headed to a height of 3. And then the limit as x approaches 0, coming in from the right, we are also headed to a height of 3. And so then the limit from the left is the same as the limit from the right. Notice that notation, and I need to be specific and say 3 equals 3. And then finally, we can declare the answer. Therefore, the limit as x approaches 0 of g of x equals 3. If we only wanted to evaluate, we could just use the sloth and say, oh, from the left and the right, we're heading to a height of 3. But because it says justify, evaluate and justify, I need to write all of this. Last example. Here we go. The limit as x approaches 6 of g of x, we want to evaluate and justify. If I only wanted to know the answer, I might go to 6 and say, uh-oh, there's a break. And we know from the Sloth definition that if there is a break or an asymptote at that x value, then the limit does not exist. But we have to formally justify. You cannot say evaluate and justify and go with, oh, well, the answer is does not exist because there's a break. That is the same thing as saying because it looks like it. And that is not going to suffice on the AP exam. So we're going to need to use this 3-part definition, starting with number 1, using the correct notation. We want to write that the limit as x approaches 6 from the left of g of x. Notice as we come in here from the left-hand side, we are heading to a height of 1. All right, then coming in from the right, the limit as x approaches 6 from the right of g of x. Coming in from the right, notice as we come in from the right, we are heading to a height of 2. Now, both of these, we couldn't stop yet because really number 1 is about saying that we can get an answer. The limit exists from the left, and it did. It has a value 1. And the limit from the right has a value. It is 2. So we haven't run into any issues with the definition yet. It isn't until step 3 when we want to say that the limit from the left and the limit from the right are the same. And of course, 1 does not equal 2. So we can finally declare, therefore, the limit as x approaches 6 of g of x does not exist. It's because it's breaking that step 3. You must write all of this. Oh my goodness, I know it's a little painful. All right, but you must write all of this. And on the assignment that you have today, you're going to be doing some problems that you've got to use the formal definition. So one more time, please do not see the directions that you want to evaluate and justify or evaluate and give a reason and say, oh, this limit as x approaches 6 of g of x doesn't exist because there's a break. That is not a justification. You've got to use the formal definition. All right, see you later.